Welcome to Advent of Code 2020. Today we are working on day 22. By the way, don't forget to drop a like, it really helps a lot. Thank you for all the support in this series. It's really fun. It's really fun for me to record videos and see all the support, so thanks. So today we are focusing on day 22 and we have something called Crab Combat. We are playing with a deck of cards. And basically we, like player 1 is playing against player 2. What happens is that player 1 takes the top card of his deck, player 2 takes the top card of his deck, then we are matching 9 against 5, and here 1 has a higher number, so they win the round, and means that they take 5 and 9 and they add it back at the bottom of their card deck. And yeah, we are just gonna need to make this game playable. So one thing first is that when you have a deck of cards in JavaScript, you always think about an array, because a deck of cards can be a stack where you add and remove from the top of the deck of cards, or it can be a queue when you add or remove from the top and add or remove from the bottom. In that case here we want to take from the top and push at the bottom. So let's do first of all some parsing, but we're definitely going to be using an array in order to do this queue in JavaScript. So here we have 2 players, so we need to split on the double line return. And then here we actually don't care about player 1, player 2, because I think player 1 should always be first. Let's check this on the puzzle input. It's always okay. Player 1 is always first, so we don't care actually about the player 1 line. In that case I'm going to map it, cards, we're going to do cards dot split with a line return. So actually let's say string here, we're going to say let cards, and here we're going to do cards dot shift, and shift is gonna be removing the first element of the array, which is player 1. So that's really good because we don't care about player 1 at all. And yeah, here we can return cards. I'm gonna move back to a const here, and here we can say we have deck 1 and deck 2. I'm gonna log that to show how it works. Deck 2. So now day 22, we're already day 22. We're really getting closer to the end of the year. So here, you know what, there is a line return here. I want to try something else. Usually I was doing this filter here, but today I want to use a regular expression to remove the line returns at the end. Basically doing this replace here, we remove all the line returns that are in at the end of the string, and here you can see we remove this empty value. So one thing I want to do here, we want to also map to a parse int of x, and we have numbers now, 2 arrays of numbers. That is perfect for us to do the work. So first of all, we're going to be doing a loop, because of course a game of cards plays in a loop. Here you can see the round. We're going to be doing, what's the end condition? Is it a for loop? That's going to be a while loop, because this is until a specific events that we want to play again and again. And I think, okay, if one player has all the cards, they win. So it means we need to make sure, we need to do while, and we need to make sure deck of 1 that length is above 0, and deck of 2 length is above 0. That's going to be our two conditions for the game to continue running and running and running. So here const card 1, we're going to say deck 1 dots, and here do we take the card in here or in here? We take the card here. So here we need to do a shift. So one thing to note is that the shift is not a great operation because it's O of n. So if you have a deck of 100 cards, shift is going to do 100 operation to shift the array. So that's not the perfect solution here. But if we look at our output, we don't have so many cards. So that is not a problem. We can use shift without an issue. And now we can check if card 1 is above card 2. In that case, we need to push. It's the player 1 that wins, so we need to say deck 1 dot push card 1 and deck 1 dot push card 2. So here we need to push 9 in the deck 1 and 5 in the deck 1. That's good. We're going to be doing the opposite here, meaning if card 2 is above card 1, then we need to push in the deck 2, and we need to push card 2 first and then card 1, because at some place they say that it is the higher card that is pushed first. So here, for example, player 2 wins, they push first the 7 and then the 3 here. So is that it? Let's log. I'm gonna be logging, you know what, deck 1 and deck 2. Deck 1 is empty and deck 2 has all the cards. Is that it? Yeah, that is actually the end result. So we're doing good so far. Now we have to calculate the winning player's score. So we don't care if this is player 1 or player 2. What we care about is okay. So const winning deck. So we need to say if deck 1 that length is above 0, then the winning deck is deck 1, otherwise it is deck 2. And now we need to log the winning deck with something special here. So we need to do a sum. Let's do the sum first of all. You know, we're going to be using the reduce a b. So what is a and b here? This is the current value, and no, wait, this is the previous value, and this is the current value. So usually when you want to do a sum, you do previous plus current, and you want to start this at 0. So it means, and the first thing you do 0 plus the first value, and so on. But here we need to also multiply this by 10. And what is 10? It is the number of cards. So one thing I want to check is MDN reduce, because I forgot exactly what are the parameters that you can pass to reduce. In this callback, there's an accumulator, the current value, and then the index. And the index is going to be key here. Index. Because here you want to say current. Oh, current. Let's put that in parentheses. This is the current card. We need to multiply that by winning deck dot length, which is number of cards, minus the index. And this is going to be 10, 9 until 1 in the end. Let's just check that. You know what? I think we need to store that in a variable, otherwise that's a bit confusing. Const winning score. Okay, looks good. We have 306. This is it. So I think this is time already to get the full inputs and compute that for part 1. have 32,179. Oh, feels good. That was a fast one. Let's go to part 2. Okay, so there are many rules in part 2, which is going to be a challenge. But at the same time, I think we can do it if we really take it slow, step by step. So, let's do that. First of all, I want to clean a bit the code here. We have deck 1 and deck 2. This is good. So here we're going to say something for part 1. So part 1 is just combat. So I'm going to say function combat deck 1 and deck 2. And basically we're going to take this while loop and we need to return the winning deck. So return winning deck. So here const part 1 deck. We just have to combat on deck 1 and deck 2. That is it. Now we're gonna be doing part 2. And this is where the fun begins. So I think I'm going to take the same function first and we're going to be modifying it. So instead of combat, now we have something called, I believe, recursive combat. Recursive combat. Still have deck 1 and deck 2. Looks good. So first of all, before the player deals a card, if there was a previous round in this game that had exactly the same card in the same order in the same player's deck, the game instantly ends in a win for player 1. So basically we're going to be doing some recursive things and we need to check only within this game. I believe this means how do they say? A sub game, yeah. So this is a sub game. So this is something different. So here we want to do that. We're gonna need to create like const. How should we call that? Already played. Actually, this is just a set. And do we still have this while loop? I think I've read something about this. I'm gonna scroll a bit. I think there would be the same while loop. I'm gonna need to reread the prem statement here. Okay, I think we're gonna be implementing these and then we're gonna see what we do. So here we need to make sure, we're gonna keep this. I need to make sure, actually before that, we need to create, const state is equal deck1 dot join. We're gonna join with a comma plus deck2 dot join. So if we do that, that's a bit dangerous. We need to put a character in between, like a hash, for example. I like the hashes. Deck1 dot join, deck2 dot join. So that's a unique string that represents the current state of the game. We need to check. Oh. Okay, never mind. If this is, or if already played has state, in that case Boom, do something. I think it's player 1 who wins. So in that case, we need to return deck 1. Because we said we want to return the winning deck. So here it is returned. It instantly ends, the game instantly ends in a win for player 1. So that is good. Otherwise, this round's card may be in a new configuration. Yes. Begin the round by each drawing the top card of the deck as normal. So this is exactly as before. Yes. Okay, so here, one thing that I should not forget, if it hasn't been already played, I need to store that now. So set or add state. So if it has been already played, then player 1 wins. If it hasn't been already played, then we add it to the already played array. I think we should be good for this rule. Then the second rule is, like usual, we take the top card of our deck. Now we have if both players have at least as many cards remaining in their deck as the value of the card they just drew. Let's make this if, if deck 1 that length is at least as many as card 1, and deck 2 that length is at least as many as card 2. What do we do in that case? The winner of the round is determined by playing the new game of recursive combat. So here we're going to say recursive combat here. To do. So we don't want to do it right away, just to make sure we're doing things slowly. And otherwise, at least one player must have enough card left in that deck to recurse. That is something that I've read a couple of times and I'm not sure about it. At least one player must not have enough card left in their deck to recurse. Yeah, exactly. That's actually this thing. Otherwise, here we are in this otherwise section here, and the winner of the round is the player with the higher value card. So basically, this is like previously. If the card 1 is bigger, we push stuff in deck 1. If the card 2 is bigger, we push stuff in deck 2. Okay, so that's a lot of rules, but we are making it, As in regular combat, the winner of the round takes the 2 cards dealt at the beginning of the round and places them at the bottom of their deck. So that's what we've done here. There's still like a bit of fuzziness here, something I'm not clear about. So we're gonna handle these sub games soon. Collecting cards. Okay, if you have, that was the sentence that I was looking earlier. If collecting cards by winning the round causes a player to have all of the cards they win, the game ends. So here we can say the winning deck is, because here we make sure one player both players have cards. If we go out of this while loop, then we know that we are in this specific condition where one player has all the cards, and here we have our usual winning deck rule. So I think we're good until this point. For now, we are good. Okay, so here we have an example of a game that would loop forever. So the problem right now is that we haven't implemented the recursive thing. So we're going to take this, we're going to paste it here, because that's one test that's going to help us. So during a round of recursive combat, both players have at least as many cards in their deck as the number of cards that just dealt. The winner of the round is determined by recursing into a sub-game of recursive combat. So this is exactly what we want to do now. We want to implement the sub-game in recursive combat. So to play a sub-game of recursive combat, each player creates a new deck by making a copy of the next card in their deck. Okay, so we need to make a copy. Quantity of cards copied is equal to the number of cards they drew to trigger the sub-game. Okay, so basically, this number is going to be helpful to extract. So here we need to say the new deck 1 is deck 1 dot, and I think we want to use a slice, I believe, to extract. Okay, perfect. Slice returns a shallow copy of a portion of an array into a new object. This is exactly what we want from start to end. So here we want to slice from start to end, and we want quantity of card copied is equal to number of the card. Okay, so basically we need to do slice between 0 and card 1. This is our deck 1, and we need to do the same for deck 2. So recursive combat of this and this. Oops. I think this is what we want to do. During this sub-game, the game that triggered it is on hold and completely unaffected. No cards are removed from player's deck to form the sub-game. So that's what we are doing. Here we're doing a slice, so we are not touching deck 1, we're just extracting, making a copy of the deck 1 between 0 and card 1, the value of card 1, and we're doing the same here, so we're not touching the current game. Okay, so what if we run this? I think this is going to be a mess, right? No, day22.js. Something bad is happening. Wait, here, what do we do when we've played the recursive combat, but what do we do with this recursive combat? Here we are returning the winning deck. That's it. Winning deck. So here, I think we need to do this. The winner of the round is determined by playing a new game of recursive combat. Okay, so now we don't care about the deck of the winner. We care about the winner ID. This is player 1 or player 2. So what we're gonna say, winner. Here this is player 1, deck. Here this is deck 1. So we're gonna be returning an object instead of returning a value. So here return and here we're gonna say 1 or 2. So basically now we're gonna return the winner and the deck. Here, winner and deck. So here we can get const const winner and deck. And now we can say if winner is equal to 1, then we do something like that. Otherwise, we do something like that. Because here we don't care about the deck, we just care about the winner. and here, in the end, we care only about the deck. I think this is not super clean, you know. Here we're gonna say let winner player equal winner, and here we can copy that because that's a bit, and here we can say if we can say player equal card 1 is above card 2. In that case, the player 1 is winning, otherwise the player 2 is winning. And with that, we can remove all of this. Is that working? No, we still have an infinite loop. Let's see. So I think we need to debug, you know, this a bit. So here we're gonna say log winner. Let's check this out. Oh wow, running forever. Wait, we're never calling recursive combat. Oh, my bad. The deck are empty. Okay. I don't know exactly what I've changed, but I've messed up the code. What is this? I need to remove this. Let's retry that again. Okay, no. Okay, well, I'm gonna be fixing the code for a second here. We have deck 1, deck 2. Let's comment out part 2 for a second. Part 1 is not working anymore. Look, deck 1, deck 2. Oh, you know what? We're using something that is playing forever, so that's really bad, and that's why we have this issue. So we're gonna be hiding those two, and we're gonna keeping this here, and we can call. So we're actually gonna reload the decks. Function load. Okay. You know what? I'm making too many changes. It's bad. So here we have deck 2 and deck 1. Here we can hide that, and now we can call the recursive combat between deck 1 and deck 2. And we need to get the deck in the end, const deck. And we need to do this winning score again. Now we're just going to be pasting that here. Let's see. So we have winner is not defined here. Winning deck, we need deck here, and have an issue in here, winner. Oh, here we need player. I'm making some mistakes, you know. Okay, the end result is 105. I don't know exactly at which step of the implementation I am, because there are a lot of rules, and this is a bit complex. Okay, so here I believe we have a bug. Is that right? So I think we're gonna need to like display this kind of information here. So here we're gonna say let turn equal 1. Or we're gonna say turn equals 0 here, and here we're gonna say turn plus plus. So we need to say player 1 and player 2 deck. So we're gonna say log deck 1, deck 2. Let's oh wait, we need to display the turn as well here. So if we go to the beginning of this, turn 1, deck 1. Oh wait, this is not the right input here. This input is just to test the recursive combat. Here we have this deck, which is the game from the beginning. Wow, I don't feel this is very complex today, but I feel like I'm a lot more confused by the prime statement, which is more complex to understand. 291. 291, so actually we've got it right. Yeah, with that we managed to stop the infinity. Here we are doing the recursive combat, so we can remove the to do. We have our winner, and depending on our so actually I don't like this player. Here I want to rename this player into winner. So now I can say winner equal player. Because the variable was a bit confusing, so now it's a bit cleaner. We check who are the winner. In one case, one scenario, we do the recursive combat and we get the winner in the variable player that we store in the variable winner. Here, if we don't have a recursive combat to do, we do this this normal scenario. And in case we have reach the end of both decks, we are checking we are using the player with the winning deck. And in case we can leave that. In case the game has already been played, we return one of the two options. So you know what? I think it is time. It is time. It looks solid. Let's try this out. Oh wait, this is working. I thought I had an infinite loop and I was a bit scared for a second. Let's see, is that it? This is it. Thank you so much for today. Please drop a like, comment and subscribe as well. I'm gonna be doing a little bonus here, which is cleaning up the code. So in that scenario, we want to be able to make those two games and display the two results. So here, instead of using deck 1, I'm going to be doing a copy of deck 1 so that I'm not modifying deck 1 itself. Part 1 deck, here console winning score. And here we're going to be doing the same, you know. Oops. I think we should have, no, winning deck is not defined. Oh, here this is part 1 deck. Okay, so I believe this, yeah, this was our first answer. This is our second answer. So we have cleaned the code. This looks good. Yep, this is all for today. Thank you so much for following this series. I'm having a lot of fun, and we're also getting close to the end of this challenge. So yeah, just a lot of excitement to have completed this. Thank you so much for today and see you in the next one. Bye bye.